Hello, everybody. We're here to talk to you, to tell you about how we're starting to deal with accessing cloud resources from CI at Grafana Labs. We know it's not super new stuff, but we think our approach is pretty nice. And hopefully, by the end of the talk, you will all agree. As Danny said, we're Dimitris and Iain, software engineers on the platform team at Grafana Labs. So here's what we'll talk about. We'll take you through our current situation via an introduction to OIDC and our new state with keyless access to Google and AWS resources. Since we're an open source company, a lot of this is open source too, and we will try to show you where this stuff lives and how you can all use it. We're in the middle of replatforming our CI to GitHub Actions. This talk isn't about that migration per se as a whole, but one part of it, secrets. This command here is the kind of thing organizations tend to end up with all over their code base. A CI job needs to do something on GCP. For that, it needs to authenticate itself, and typically that is done by generating service account credentials one time, storing them somewhere, and then passing those to the cloud SDK from the CI jobs. You can think of these credentials as a username and password in one, and they have all of the same problems. Two of the main ones, they never get rotated, and if they are leaked, then whoever obtains a copy has full access for as long as it takes you to detect that this has happened, which might be a really long time. So every CI system can be used in this way. Here's what it might look like for an organization already on GitHub Actions. Secrets can be in many places. They might be in GitHub secrets as they are here, in something like Vault, in your cloud providers, key management service, etc. They tend to reproduce like rabbits. Fun thing that happens with GitHub secrets is that you're limited to seeing 100 at a time across both repository and organization secrets. If you can see more than 100, you silently receive only the first 100 you can see. Please come and talk to us after the talk and ask us how we know. So how many times did you have to find the right secret when there were secrets named like API key, my company API key, access token, API token, etc.? It's always hard to find the right secret in case of an emergency. Also, static secrets are prone to leakage, and especially when there are too many, it's difficult to rotate and hard to audit. But this is also another problem, abusing secrets. We need to know what should be a secret and what should not. Not everything needs to be a secret. Over-securing data adds unnecessary complexity and overhead. Non-sensitive configurations can be safely exposed without risk, freeing up resources to focus on protecting critical assets. Also, like in the previous example with the multiple keys, it's hard to audit and may also affect the speed of development. So let's move on to the solution for some, not all, of the cases. Spoiler alert, it's OIDC. Due to our limited time, we won't go into many of the technical details here, and the equation isn't technically correct either, but don't think about it too much for now. For everyone that doesn't know, I will try to quickly explain what OIDC is. It follows on from a couple of technologies that came before. So OpenID was an early attempt to create a decentralized authentication standard for the web. It allowed users to log into multiple websites using a service identity. OAuth 2.0 came later as an authorization framework. It allows applications to access resources on behalf of a user without the user sharing their credentials to the application. As an application, you receive what's called an access token, and you supply this back to the originator to access resources as the user. Neither of these standardize a way to access information about the user. That's what OIDC brings us. Building on top of OAuth 2.0, IDC adds a new standard type of token called an ID token. We'll see one of these in a minute. With the ID token, you can know who is accessing your API. OIDC can be used both in cases where a user is present, like logging in with a Google account, and for machine-to-machine use cases like our CI one. But most of these details are handled for us by GitHub and cloud service providers. We will focus on the ID token itself and what you can do with it. So let's show how we do this from GitHub Actions then. The first thing that's going to happen is that we need to get that ID token. To do that, all you need is this permission in your workflow file, ID token write, then you can access an endpoint. Unless you're writing an integration yourself, you probably want to use a third-party action to do this. So this will give you a token. Think of this token as a piece of proof that the request comes from a particular workflow run. The token contains properties, which are called claims, which can be used to verify it's valid. What you actually receive, basically, is a base64 representation of this token, with some other information, such as its signature, etc., which aren't shown here for brevity. So the OID claim, which is short for audience, is about who the issuer intends the token to be used by. An endpoint can check to see if the token was meant for them. In GitHub Actions, this can be set when requesting a token, and we would recommend you to do this, so if there's a leak of tokens from one workflow, the scope of the compromise is limited to that one only, because the audience will be wrong for all the others. The other claim, ISS, which is short for issuer, is about who issued that token. This will definitely need to be checked, and we'll show you later why. And some timestamps, like not before, like expiry or issued at, which say when the token is usable to prevent replay attacks. If you're handling ID token JWTs, it's crucial to verify all of these, so you can just be given a forged token. In our cases, GCP and AWS will be handling most of these for us. They will check the signature, the audience, and that the token is valid and hasn't been expired. And then, once we're happy that the token is valid, we can use it. As a side note, the claims in italics here are the standard ones. We've not discussed the sub claim, which is the subject. As this is an ID token, the subject is what is being identified by the token. In the CI case, it's the workflow. If we're working with social login cases, for example, this might contain information identifying the user, which you could use as a key in a database. The rest of the claims, the ones in bold, are not standard, but for the GitHub Actions case, they look to be much more useful. Since we're not interested in ID tokens in general for this talk, but ID tokens which come from GitHub Actions, we're able to assume that these non-standard claims will be present. There are useful properties about the run itself. Let's see what we can do with those. Here's what we do with Google Cloud. This uses a product called Workload Identity Federation. The idea here is that you can take workflow runs and give them access to your cloud resources. You configure your OIDC provider. Here are some screenshots from our configuration at Grafana Labs. By the way, this is a real URL. We'll talk about how that's not a secret later. It's also in one of our public repositories, so no need to write this down. We'll give you the name of the repository a bit later. Note, we can see two of the claims we just saw on the previous slide, the audience and the issuer. We noted how it's important to validate these, and that's what we're configuring now. So we create a service account, which is a machine user in our Google project, and then give it permissions to use the Google AI platform, since that's what our example uses. This is what the top screenshot shows. The second screenshot is where we say which workflow runs are allowed to use this service account. We won't go into the full details due to time, but the highlighted part is the most important part here. It's looking at the repository owner claim of the ID token and checking it is Grafana. This is a pretty simple check. This is using a GCP concept called a principal set. As we saw a couple of slides ago, the GitHub ID token contains a lot of information about the run. We're never interested in checking all of those claims at the same time, but just some of them. So defining access in GCP is done in terms of sets of workflow runs. This one is the set of all workflow runs where the repository owner is Grafana. And then we can use an action provided by Google to get access. What happens is the action sends a request to GitHub's ID token endpoint. It takes that token and sends it to our workload identity provider to get a Google Cloud federated token. Since we asked for an access token for a service account, there is then a further call to get this access token. That's provided as an output to the step, and once we have it, we can use it in any way we want. Here, for example, we use curl to get Gemini to tell us a nice story, which is lovely. And then here we are trying and failing with a direct copy of the workflow running under Iain's personal user, not the Grafana organization. This is because the repository owner claim, which we were checking, no longer matches. This isn't possible with static service account credentials. If you have them, you can use them. They don't carry any context about where the request came from. And this is a question we ask ourselves all day as platform engineers. What do our engineers do all the time, and how can we make that easy? What are we here trying to build at the end of the day? We're providing things for our engineers to use to ship the company's products. How do they do that, and how can we make it easy and secure? Thinking about this for a while in this context, we might come up with some bullet points that look like this. So we have an internal monorepo, which contains all of our infrastructure defined as code in Terraform. Engineers are very used to working in this monorepo, as we've had it for a long time, and they self-serve most changes using the interfaces as the platform team, our team, provides. And what is a common thing to do from CI? At least for us, it's kind of common to want to build and push Docker images or artifacts or whatever. Most of our projects are distributed like that, for example. So we set out to build reusable components. What resources do we need to push a Docker image to GCP, for example? We need a registry to push to, and we need a service account which can perform that pushing. You might want that registry to be private or public. You might want one for dev and one for prod or any other environment you're using. For a private one, perhaps CI workflows will need to be able to access it. That's a set of requirements that can be easily fulfilled by a Terraform module. So this is what we're building. Running the Terraform code from the previous slide will create a service account and will assign a workload identity user role. We can see that the principal set here, the same concept I explained a couple of slides ago, is checking the repository's ID. That means that access to this service account is specific to the my SREcon repository, like the test repo, GitHub repo. This is really important when it comes to being more strict about which service account has access to which resource. Our strategy here is that there should be one service account per GitHub repository. One thing to do one job. Even in case that all hell breaks loose and something is leaked, we know that this service account didn't have access anywhere else. Say now we want to add a Docker repository in Google Artifact Registry. In the previous Terraform code, we can add this repository config block, for example. Other formats can be, of course, NPM or RPM or Java, Python, Go packages, etc. So what will be generated from this new block? As you can see here, a new JAR repository is generated, which of course is still empty. If we check the permissions for this repository, we can see that the previously created service account has already artifact registry writer permissions to it. Remember what we said about one GitHub repository only pushing to one GAR repository. This image shows exactly this. This means that now we're ready to push to and pull from this GAR repository, from workflows that live in the aforementioned GitHub repository. Similarly to GAR, we can now add another block to create a GCS packet. Again, there's a new service account created along with this GCS packet. One important thing to notice, though, is that the service accounts generated for GCS are different than the ones for GAR, and this is pretty important. One thing to serve only one purpose. So, okay, we have the service accounts, we have the GAR repo set. How can we actually use them? So on the left, you can see a workflow which is responsible for pushing to GAR. One needs to specify the registry, the image name, or provide Docker build arguments or whatever. On the right-hand side, you can see how the action handles the login to GAR part, the authentication part. A service account is constructed based on the repository ID from an environmental variable and the environment that we provide as input, either dev or prod or whatever. Then, using the workload identity, as shown in previous slides, and the workload identity federation service account, we create an ephemeral token. This token can be used to log into GAR. You already have noticed that we may be exposing too much here. The security of the system is not enhanced by trying to hide it away. It's the opposite, in fact. By knowing that it's out there in public, we are forced to confront that fact and design things so that only what we want can access our stuff. And with that, handing over to Iain.
Okay. So just to come back to the theme of the talk, we have not seen any secrets yet, but there have been some which have happened behind the scenes. When the actions call cloud service provider APIs to authenticate as a machine user, they get back a token, which we must treat as secret. The tokens have a limited lifetime and can be revoked at the end of the workflow, but if people can get their hands on them, they will be able to use the access they provide. They're a bit like the old static credentials, which we've got rid of, except, as I say, with a limited lifetime. So always make sure that you handle the tokens securely. Never print or store them, only pass them directly to other programs. Usually you'll hand them to one of the cloud SDKs or authenticate to a cloud CLI using them, which is just fine. But with that said, we've just shown you how to interact with Google's APIs in a couple of ways, and all of the code that we've written to do that could be made public without making us any less secure. There are no secrets in that, and there are certainly no static secrets, which are the ones we're really worried about. So with that said, let's talk about open source actions and ways to share workflows. Since there are no secrets involved, we're going to say this a lot, by the way, there's no problem doing this. This repo, Grafana Shared Workflows, is part of our overall CI migration that we talked about at the start, but plenty or maybe even most of the shared actions in there make use of OIDC to do their tasks in a secretless way. The goal of this repo is to provide a space for common CI tasks to be used by our other open source and private repositories. Go and check it out. In there, you'll find various pieces of information about our infrastructure. You'll find the workload identity federation endpoints that we talked about and showed earlier, and their equivalents for AWS. You'll be able to tell how we do some of our deployments internally, even if you can't actually see them. You'll find URLs to some of our internal tools, like Argo Workflows, which we use for rollouts. You'll find the names of some of our internal clusters. And if you look hard enough, you'll find the name of the repo with our infrastructure as code setup, which is the Terraform stuff that Dimitris showed you a minute ago. We want as much of this out in public as we can to force us not to rely on security provided by keeping these things secret. These things do exist, and by trying to hide them away, we just fool ourselves that only we know about them, which is a way to put less focus on keeping things truly protected, aka security by obscurity, which as we know is fake. But we also do this because of this. We just want to have as much of this in the open as we can. Now, yeah, admittedly, this is a bit of a cheesy slide. This is one of our company's values, which I actually stole directly from an internal slide deck that gets shown to new joiners. But it's personally what attracted me to this company, to be honest, as I've spent my career in open source. And when I was looking to move last, I wanted to stay in that world. And it does apply strongly to this project. Firstly, it means that we just want to be open source wherever we can. But more practically, our main projects as a company, Grafana, Mimir, Loki, Tempo, and so on, they're all open source repositories on GitHub. And while you might technically be able to have their CI be private, that's really no way to run an open source project. We want them to be able to use everything that we've built just as much as any private repo can. So it was an early decision that we would never make any choice that would cut them off from what we've built. To be honest, having this repo with so many of our implementation details available publicly felt kind of spicy at the time, and it still kind of does to us occasionally. But we always come back to reconfirming the decision. And anyway, it's too late to go back now because this is public commits. And as we know, once you push a Git commit publicly, you consider that it's out there forever. But okay, let's switch gears and bring things down for a little bit. I want us to talk about how easy all of this is to get wrong. You might have got a sense about that already. So this is a security advisory that we got a few months ago, and it was actually from before we'd started working on this particular project. It was related to an internal hackathon project, which also made use of OIDC from Actions, and the learnings fed into some of the things that we've done here. The team had forgotten to check all of the relevant claims on the tokens, which Dimitris talked about a minute ago, resulting in a state where unrelated repositories could access resources that they weren't meant to access. In particular, they forgot to verify the repository owner. Fortunately, this wasn't too bad in this case, since the hackathon project was running in its own GCP project, so it didn't have access to any production or even dev resources, but it's still a cautionary tale nonetheless. The lesson is you have to remember to check the claims every single time to be secure. If you're reading carefully, you'll have seen that the reporter of the security advisory made two claims as to the cause of the issue. First claim that they made was that the parameters, the workload, identity federation ID in GCP, or the OIDC URL in AWS, are not kept secret. And as we've mentioned several times already, we disagree with this. One of the main points of this whole thing is to get rid of secrets. We don't achieve that goal if we remove individual secrets, but then there's a super secret URL which would blow things open if it was revealed. It implies that we're in serious trouble if those values ever become known to the public. Unfortunately, that's not the case. The receiver of the ID token can be public as it is validating the token itself. It doesn't matter if everyone in the world knows the URL, if only the right people can obtain tokens which it will listen to. It goes without saying that this assumes that the receiver is validating properly. Don't roll this stuff yourself if you aren't very experienced. Rely on the implementations of major vendors like Google's, which we've shown here, and AWS's, which I'm going to show you on the next slide. So let's show you how this kind of vulnerability can happen. Just for fun, and since we've not seen an AWS example yet, even though the vulnerability was given for GCP, we'll show how the same can happen on AWS too. It's a bit of a contrived example, but bear with me. We've created an OIDC identity provider in our AWS accounts, and this is a resource much like the workload identity federation pool provider that we saw before. It allows non-AWS identities from an OIDC provider, which in this case is GitHub Actions as ever, to access AWS resources in your account. As always, we check the issuer and the audience, and this part is correct, and it's necessary but not sufficient for security. In AWS, we use IAM roles and trust policies to control what can be accessed and when, but OMG, in this case, we made a mistake. We remembered to lock down the repository name, but we used a wildcard where the repository owner would go, silly me. And sure enough, while our intended repository could read the file, so could another one with the same name in a different organization. Both of these runs succeeded, but we only wanted the one on the left to. Whoops. And the fix here, as you might have guessed, is to specify a condition on the subject claim properly. For example, if we wanted to lock down to main pushes only on this repo under my user, we'd do this here. And then when we run the same workflow again, access is denied this time, just like we want, which is shown on the right. Now, of course, relying on the end users, the engineers, to get this right every time is a recipe for having incidents like this. If it wasn't possible to centrally lock this stuff down, then it would feel too scary to roll this out to the entire organization. But one of the things that we as a platform or SRE team can and should do is to solve things centrally for teams. And here's one way to do this for GCP. In Workload Identity Federation, you are required to define something called an attribute condition, and that's what's shown on the screen here. This is a condition which is checked for all requests before we check the access condition to the resource that was requested. If this condition isn't satisfied, in this case, if the repository owner isn't Grafana, then the request will be refused. We are shutting unwanted requests out at the front door so that engineers can't possibly get this wrong. And this is what we actually do. Just as you hopefully don't have GitHub secrets available to your forks, here we don't have CSP access available to ours. We've prevented this from the center, meaning that even if engineers end up granting really wide access to their resources, they won't be able to go any wider than this. Speaking of granting really wide access, as the platform or SRE team, we really don't want to be in the business of provisioning resources for teams to use or specifying in detail exactly how to use them. It is 2024 after all. No, what we provide is a toolkit which sets teams up for success, enabling the correct behaviors and preventing or at least discouraging the incorrect ones. One of those in this case is too broad access. It can be difficult to know when your resource will be used in CI, and the IAM concepts are easy to get wrong, even for people who know it all very well. In this case here, any CI event on this repository is going to get access to the role. It might be fine, it might not. You need to weigh it up for your case. If you have infrastructure as code which engineers interact with to provision what they need, provide access to all of this stuff through libraries with simplified restrictive interfaces. While you're learning how it all works, be high touch with a few pioneer teams and work out what the common needs you need to enable are, and then write these down in the form of reusable components that they can interact with. For example, and this is what we do in our case, as we showed earlier, this might be Terraform modules. You can get very, very fine-grained with all of this, locking down to the level of individual workflows if you want to. Each organization will end up in a different place. Work out where yours is by gaining experience through usage. And once you're there, make sure to write it down in terms of interfaces and in documentation. Setting up CI access is not most engineers' idea of a fun day at the office, especially if they get the sense that getting it wrong has terrible consequences. Our job is to make it easy for people. In a way, you can think of it as a trade-off of complexity and usability versus security. Just getting on to some top tips now. One specific top tip from us is to use reusable workflows in GitHub Actions. Really, really nice in this situation. And if you don't know what they are, you can think of them a bit like Lambda functions. Imagine your CI is calling a function in a different, possibly remote library. So on the screen, we have a reusable workflow on the left-hand side and a normal workflow on the right-hand side, which is calling that one. With this, you can separate your CI code from the code being tested. And if you set things up like we've done here, using the workflow on the main branch, then CI code must be merged first before it can be used by pull requests. This can be really nice in some situations. For example, if the CI workflow isn't executing code from the calling repository, it can mean CI cannot be used to execute privileges. In the case without reusable workflows, where CI workflows live in the same branch as the code being tested, the entire CI workflow could be replaced and have all of the same access. With OIDC, it means you can lock down access to exactly the single workflow that needs to access the resource at an exact reference to. When an ID token is requested in a usable workflow, it contains a special claim called job workflow ref, which can be verified on the receiving end. And that's what is shown at the bottom of the screen there. This means that access to the resource can happen if and only if your reusable workflow is used. For some of our shared workflows, we use this to require that engineering teams go through the shared workflow and don't re-implement the same thing themselves. One example you can find in our shared workflows repository is the reusable workflow to sync Backstage tech docs to the bucket that it uses. This bucket can only be accessed via this particular reusable workflow, which means that repository CI runs can't arbitrarily wipe files in the tech docs bucket, and access to this shared resource is controlled by the team that owns it. The calling workflow just asks for a tech doc scan, and it can't influence what the reusable workflow does. As far as we know, it's implemented properly, and so the tech docs bucket is safe from changes, even though the reusable workflow does have full access to it. So, a call to action from us. These days, when I find myself having to create a static API token, I go through the following series of existential crises. Number one, feel bad about not having a strategy for rotating it. Number two, worry about storing and keeping it safe. Number three, gnash my teeth because I can't make it available to only some of our CI workflows. Number four, have a sad and empty feeling inside my soul because I can use OIDC over there where there are rainbows, but not here with all the sharks. Wouldn't it be nice if our souls could be cleansed more often? We think it'd help if we supported machine-to-machine OIDC in all the places. So this is the call to action. If you or your team or your organization are responsible for an API which uses API tokens for auth, consider additionally allowing access with ID tokens. Then your users will have one less secret to manage, at least for the cases where there's a way to get an ID token, like there is in GitHub Actions and most other CI systems you're likely to be using. But nothing is free. This is still code running on computers. It's not so different from securing your APIs. The fundamentals of securing systems apply here too. Any input your CI workflows take from the user is a risk. It's easier to imagine how allowing pull requests full access to production S3 buckets could result in a business disaster. Consider what would happen if a malicious actor gained the ability to open PRs in your repository. Maybe they compromised an engineer's account, for example. Right, this is the last content slide. Now you know what OIDC is, and you've seen how to use it from GCP and AWS. You've seen how it can go wrong. One of the most important things we want you to take away from this talk, which is why we said it several times, is how almost everything is public. By putting our endpoints in a public repo, we have forced ourselves to rely on and trust in the inherent security of the system itself. It's scary, but ultimately we believe it's the right decision. A lot of our work can be seen in the Grafana shared workflows repository, and we'd like you to go and check it out, please, because we have a bug bounty which covers all of this. So we'd love it if you would go and find our mistakes for us and then responsibly disclose them to us. And it's beneficial to you and financially beneficial to you and morally beneficial to us. So win-win for everybody. Right, that's it. There's so much more that we could have talked about that we didn't have time for. We didn't tell you that AWS only supports the subclaim natively and not all of the other lovely ones which GitHub provides and which we showed being used in GCP. We showed you how to fix the too broad access by looking at that subclaim, but the approach we showed requires each role to be configured correctly, which, as we explained, is something that can be forgotten and really should be done centrally by our teams. We have resolved both of these problems at Grafana Labs for AWS by using Cognito, which is a whole hairy thing and could be an entire very technical talk in itself. But you can see the AWS auth shared workflow for a few of the implementation details. With this, we can look at any property of the run, any of the claims, and we can impose a minimum level of central control. We didn't tell you how there are still static credentials around. This is the real world after all. And not every provider supports OIDC just yet, nudge, nudge. And how we can still use those static credentials via Vault. Now, if any of that stuff sounds interesting, well, come and find us afterwards around the conference and we can show you what we've done. And with that, thanks. We're happy to take any questions.